is the laws of motion we are discussing. Let us write some definitions regarding the chapter. The first definition we have the inertia. So as you can see on the board, the definition is given here. The tendency of a body at rest to remain at rest, or of a body moving with uniform velocity in a straight line to stay in motion with the same uniform velocity when the net external force is 0. So this definition you have to write in your copy. This is the definition of the inertia, okay, which we also call as the first law of motion. Okay, then the second one, that is Newton's second law of motion. Let us see the Newton's second law of motion definition. Okay, see the second definition. Before doing the Newton's second law, we have the second definition. Momentum of a body is defined as a product of its mass and velocity and is denoted by the small letter p. So this is the definition of the momentum. And what is the meaning of the momentum? It is the amount of motion contained in a body that we call as a momentum. And the value of the momentum, that is a formula, we have p is equal to m into v, that is mass into velocity. And the unit, if I consider, it is kilogram meter per second. So you can write a unit in your copy. Then next we have the Newton's second law of motion. The Newton's second law of motion states that the rate of change of momentum, okay, of a body is directly proportional to the applied force and takes place in the direction in which the force is x. So this is the definition of the Newton's second law of motion. Then we can go to the Newton's third law of motion. So the Newton's third law of motion states that every action has equal and opposite reaction. So this definition you have to write in your copy. Now I am going to do what are the applications of the Newton's laws of motion. So let us discuss one by one. Okay, let us discuss the first Newton's second law of motion. You can see on the picture there are two scenarios. There is scenario 1 and the scenario 2. So in the scenario 1 and scenario 2, if you see the difference, what is the difference in both the objects? If you see here, the boy, he is catching a ball. The size of the ball is little bit smaller, and if you go to the second scenario, the size of the ball is little bit bigger, if it is clear to your picture. Okay, now if I see in the scenario 1 and scenario 2, you can see the mass is taken as mass m. The second one is double that of the first object. If I calculate the velocity by using the Newton's the equation of motion, that is the third equation of motion, we have the formula v squared is equal to u squared plus 2as. This is our formula. But since it is acting under the action of gravity, so what we have to consider, initial velocity will be 0, will be equals to 2gh, because you can see the displacement is here, it is written as h. So v square is equals to 2gh. So if I calculate a v, so v will be equals to root over 2gh. Now if I calculate the momentum, what will be the momentum? It is mass into velocity, as I have already discussed. Mass into velocity. So mass into velocity, we have got v square is equals to 2gh. So what will be v then? V will be equals to root over 2gh. So you put it here. So mass into velocity, mass into root over 2gh. So the force one will be getting, suppose as F1. Now if I go to the scenario 2, value will be exactly the same, but only the difference here is the difference in mass. So if the difference is mass, that means if the mass increases, obviously the force will also increase. The more the mass increases, the more the force will increase. Since the mass is increasing twice, so the force will also increase twice. So here, if I consider who will get more hard if he catches the ball, obviously the second boy. Why? Because the amount of force acting on his hand is more, so he will be getting more hard on his hand. So this is the applications of the Newton's second law of motion. So let us discuss few more examples. So let us see the next example. As you can see, we have a player. So the player is catching a ball. So suppose if the player catches a ball, so how does he catches the deuce ball? So let's say check. So as you can see in the video, the player or the wicket keeper, he has lowered his hand, he has moved his hand a little bit inwards. Why? Because to reduce the effect of the force. Because as he moves his hand inwards, the amount of time, effect increases. So if the amount of effect time increases, as we know that force is inversely proportional to your time. The more the time, the less effect will be force. So if he moves his hand inwards, so the effect of force in his hand will be less. That means he will be getting less hurt. But if he directly catches the ball, he will get hurt in his hand. So this is some strategy while playing a cricket match or for the wicket keeper. So this is based on the Newton's second law of motion. Okay, so these are some examples related with the Newton's second law of motion. Let us move to the Newton's third law of motion. Okay, the next we have the Newton's third law of motion. So as you can see, a person is pushing a wall. As we know, he cannot push the wall because that is a static and this is having a more amount of force than his muscular force. So as you can see in the video, he is trying to push the wall, but he is not able to move the wall. Why? Because there are two forces acting on his hand. Okay, one is your muscular force by the body A. The other one is a force given by the wall. So that is called as a reaction force. Okay, so action is given by the hand, reaction is given by the wall. So why he cannot move the wall? Because of the action and the reaction force. Similarly, if you see here the two person, okay, the two person is boxing each other. So if he boxes each other, so what happens? They used to box each other. So suppose one person gives an action. So suppose the other person reacts and put his hand. So what will happen? The other person who is boxing, so he'll be getting hurt. Why? Because of the reaction force. Similarly, we have some more examples like the rocket propulsion. So when the rocket flies, as we know, when the rocket flies, there is an ignition which comes below. So that fire, when it hits the ground, it enables the rocket to move in a forward direction, that is towards the upwards direction. That is called as a reaction force. The ignition one is the action one, and the force given by the ground is a reaction force. Okay, similarly, if I suppose, suppose if I throw this one only, if I throw this one, but this is not an elastic one, if I throw this one to a wall, what will happen? When we throw this to the wall, it will be having a force on the wall that we can consider as a force. And the force will be applying an equal force to this pencil. Okay, to this pencil. So what will happen? This will be bouncing back. Why? Because of the reaction force given by the wall. Similarly, suppose if a person, when he moves by the river and he moves to the, he moves to the seashore and he wants to jump from the boat. So what will happen? He will put his toe finger, okay, he will put his toe finger on the boat and he will be jumping, okay, by giving a force from his toe finger to the boat. So the toe finger will apply a action force on the boat and the boat will be applying a reaction force on his toe so that he can jump forward. So these are some examples related with the Newton's laws of motion. So in the next class, we'll be discussing some more topics related with the laws of motion. We'll be discussing about the momentum, we'll be discussing about the impulse effect and some more related with this chapter. So this much for today. We'll be continuing in the next class. Thank you.